All right, everybody, welcome to, let's see what day we are. So this should be, let's see, down here. This should be the 26th. So you just had a day off on the 25th. That's Tuesday. And today, what we are going to do is we are going to go through some review of just some general stuff that we've done with acids and bases in chapter 16. And then we're going to talk all about pH, which is a huge deal in AP chemistry. All right, so let's get started. Let's jump right in. So first and foremost, you should remember some general characteristics of acids and bases. So for example, you should know which one feels slippery. Okay, and so your options for this is acid, base, neither, both. Okay, so the one that feels slippery, that's a base. The one that tastes sour, this is an acid. More H plus than OH, well, that's an acid for sure. Equal H plus than OH, well, that would be neither, right? So that's C. Reacts with metals, that's A. Turns litmus paper red. So red oftentimes is an acid color, so this would be an acid. Turns phenolphthalein pink, though, that's a base. So base is in phenolphthalein. Bitter, so that is also a base. Electrolytes, this happens to be both, right? So it can be, they're both electrolytes. Causes color changes. Well, they both do. They just happen to have different colors. Can be neutralized. Well, they both can. A little string of boths right here. And then feel squishy. Okay, don't get tricked, people. None of these feel squishy. First of all, I never really liked that they're feeling stuff, but there's none that feel squishy. So neither of them feel squishy. Red and universal. Okay, so this would be an acid. Again, red is oftentimes an acid. Makes salt and water when neutralized. That's both. Most foods happen to be acids. Most cleaning products happen to be bases. Starts with H, that's definitely an acid. Ends with OH, that's definitely a base. And corrosive. So corrosive means that you eat away metals. Okay, so that's an acid. And then insoluble, that's neither of them. So they all dissolve in water. That's what makes them so. Okay, so that's just some general things. Now, we aren't going to continue doing this. We'll just kind of skip this one. But I do want to go back up to this one and kind of match these. So there's different types of acids that you can have. You can have like a binary acid, like, just two elements, or you can have a ternary acid, which has oxygen in them. So binary ones, these happen to have the hydro in it. So hydrobromic, that would be this one right here, right? So let's match these. And then hydrosulfuric, so there's no O in hydro, so boom, right? So that's the only two binary ones. And now the ick ones, this happens to be the one that's the higher version of them. So you have two to choose from. And we're going to pick the higher one. So we're going to go here, and that's bromic. It is, in fact, bromic. And then sulfuric, here we go, sulfuric, or this guy right here, right? So this one happens to be sulfuric because the ick is the higher version. And then sulfurous is right here. One more, let's do chloric, right? That one. And chlorus is the one lower. So that's kind of how you name acids, and we did that in August, but yeah, school is hard sometimes and it's easy to forget. Okay, so now this is important, all right? So this is like a major definition of chapter 16, and the fact that acids, by definition, are things that donate H+. Okay, so you're going to be looking for all right, so acids get rid of H's. So what is the conjugate base of? Okay, so if you're a conjugate base, that means you're acting as an acid. So the conjugate base of this acid would be NH2. And when you lose an H, right, you lose a positive charge, so NH2 minus. Let's do this one, right? So this is a loser. This is an acid. So the conjugate base would be OH minus. Do you see how every H you lose, you are losing a charge. And then this would be, the conjugate base of that would be CO3, 2 minus, okay? Every time that you lose an H, you lose a charge. Now, conjugate acid of this is now acting as a base, so this is NH4 plus. So every base, that's this, has a conjugate acid. That's one where they gained an H, okay? And remember, things can be, like these are all amphoteric or amphiprotic, depending on what book. But that means that you can be both, right? It can either gain or lose. And then this would be H3O plus hydronium, and then this would be H2CO3. So what you should be able to do is look at something and tell whether or not it's losing or gaining H's. Remember that acids are losers, bases are gainers. And also the conjugate just tells you it's on the right hand side. So like these are all conjugates because they're on the product side. And the pairs, like, they match up. So, like, for example, HCl matches up with Cl minus. Like, this is the acid and this is its conjugate base. And that's how you figure that out. Very important stuff. Okay, so today we're going to talk about pH, which, oh my gosh, is finally, right? We finally get to pH, which is a huge deal in chemistry. Don't want to be dramatic, but you know I am. And what makes this so dramatic and awesome is that we can actually test and measure the strength of acids from their pH. And this involves logs, people, logarithms, logs, not like wood logs, which those are cool, but like logarithms. Okay, so let's get into this. All right, so acids are substances that dissociate and produce H+. So lots of H plus means you're a super strong acid, and lots of OH minus means you're a super strong base. And if you have equal amounts, that means you're neither, right? You're just kind of neutral. So the measure of how much acid, H plus and how much base you have is determined from how the concentrations of the OH or the H plus. Okay, so a couple things here. All right, let's talk about this. So if you're a strong acid, and this is key, you're going to get the full complete arrow. So this is going to be 100% products, and you get lots and lots of ions in here. And this lots and lots of H plus ions or H3O plus gives you a really strong acid. Whereas if you're a weak acid, you are only making a portion, just a mere portion of it. Usually this is 95% reactants and like less than 5% products. So it's barely producing anything. And so you get just a tiny bit of acid 1. So this is a much stronger acid than this guy right here, the weak acid. So that's what we talk about with strength. It has to do with how much they dissociate. And what's interesting is we can measure how much they dissociate by knowing something called Kw. Now, K, if you remember from the previous chapter, is like the equilibrium constant. It means how far to the right or left it is. And water, when you measure it, they found that water, if you were to measure this, right, and concentration of it, is that this amount would be 10 to the negative 7th concentration of OH and 10 to the negative 7th H3O plus. So neutral water has equal amounts OH and H3O plus. And so Kw is just the products, H3O plus, over reactants, but you can see that these are just liquids, right? So it's just this is Kw. So it's just products over 1, basically, right? They're not included. And if this is 10 to the negative 7th, and that would be the H3O plus, and this is 10 to the negative 7th, then Kw is, if you multiply exponents, you just add them, so 10 to the negative 14th. And this constant is kind of important. And in fact, that's basically why the scale goes from 0 to 14 when we talk about the pH scale, because it's based off of the dissociation of water. Okay, now, so pH is the measure of how much H plus or OH minus is present in a solution. And by definition, pH, which P stands for potential here, is the negative log of the H plus concentration. So you're going to have your calculator. Let me see if mine works here. And, oh, there it is. We need scientific mode. So let's see if I can get scientific mode. We want scientific mode. There we go. Okay, so for example, if I have something like let's just do this for funsies. If I have something that has a 10 to the negative 3rd H plus concentration, so that means it's like 0.001 in H plus, okay, or H3O plus. So we measure it, we find out it's right here, right? So to figure out the pH, you would do the negative log of 0.001 log, and then get rid of the negative symbol. So on my calculator, I'd have to do it opposite, but it ends up being a pH of 3. And the reason it has a pH of 3 is, so 0.001 is 10 to the negative 3rd. This exponent is actually the pH. And something that is even weaker, like 10 to the negative 4th, would be 0.0001, right? This is the pH of 4. So the exponent is actually how many zeros to the right you had to move this thing, okay? So to find the pH, you just negative log it. You just literally punch in, let's say I have a concentration of, let me get rid of some of this here real quick. Trash it. So let's say we have 0.015 mH plus. So you would just negative log that number. So this would be log, let's just clear this real quick. We do 0.015, log it, and then make a positive number. It would be 1.82 is your pH. You literally just do negative log H plus. Literally, literally. Now, we also measure OH minus, okay, and there's something called the POH. Okay, so the POH is equal to the negative log of the OH minus concentration. Okay, so if I want to know the POH of this bad boy, I would take the negative log of 0.01. So we go back to our calculator, we type in 0.01 log and make it a positive number because pH is always positive, and you would get a POH of 2. So I want to show you something, and this is important. So the pH plus the POH equals 14. And the reason why is, do you remember KW is equal to OH minus times H plus, and it always equals 10 to the negative 14th? And you remember that all of these exponents are what the pH comes from. That's why they equal 14. Okay? So anyways, if you have a POH of 2, your pH is 12. You just have to subtract from 14. Okay, and you're going to play around with this a lot, so we'll spend lots of time. I like to look at it like this, okay? So there's a couple formulas you should know, all right? So first and foremost, know that you have to, if I know the pH, right? So let me show you a couple. So I'm going to draw a little chart here for you. Maybe on your notes, put this chart. So if I have H plus or H3O plus, that's the same difference. And I want to get it to pH. I negative log it, okay? So for example, if I have 0.001, I would hit negative log, okay, and it would give it to us. And if I want to do the reverse of that, I take 10 to the negative pH. So for example, this has a pH of 3. The H plus would be 10 to the negative third. Okay, so that's where that comes from. So it's equivalent to 0.001. So it's not a super strong acid. That's what it is. And then to get to pH or POH, I have to do 14 minus the pH, and vice versa. It'd be 14 minus the POH to go the opposite way, and that gives me the POH. So this would have a POH of 11, and then this would be 10 to the negative 11th would be my OH minus concentration. Because look, if I'm going back to OH minus, which I'll put it down here, OH minus. Wow. So to go from here, I have to do 10 to the negative POH. And this has kind of got messy, which is hard to write. Sorry. All right, let's try again. All right. So anyways, let me see if I can find another one. I'll give you another example. Okay, so this is a perfect one. Okay. So you're going to use that little chart or whatever I just did. So there's two options, right? So you're going to subtract from 14. You're going to get all these represent the exponents, all right? So I'm going to draw it up here just so you have this. So H plus to pH, you have to negative log. And then going the other way, you do 10 to the negative pH. Okay, so for example, right here, right? We're going to do 10 to the negative 3.2. Now, you don't leave that in there. So you definitely need to calculate it. So let's get my little calculator up. Let's go back here. So we're going to do this button, which is 10 to the negative. So we're going to do 10. And then we're going to do to negative 3.2 equals. And then we're going to hit that. Whoops. This is how you don't. And we're going to do negative 3.2. Make it negative and hit that button. Okay, so that equals 6.3 times 10 to the negative fourth. 6.3 times 10 to the negative fourth. That's what that equals right there. Then we're going to take this and to get between pH, so pH plus POH equals 14. Okay, so this is going to be 14 minus that, so we're going to have 10.8 here. So again, these give us, like, these will always equal, if you add these up, will always equal 14. So to find the OH minus, you would do 10 to the negative 10.8. And to do that, let me go back to here. So we're going to go back here. We're going to type in, clear this bad boy, 10.8, make it negative, and hit the anti-log button. And you would get, it's going to draw it over 1.59 times 10 to the negative 11th. And that would go here. Because you don't want to leave it as 10 to the negative 10.8, because that's not really how you, that's like saying like 4x plus 1 equals 21. Like, you need to solve it out. Okay, let's try the next one. Let's see if this makes sense. So, okay, so we're going to start from OH or H plus. So we know we're going to take the negative log of that number. So negative log of 10 to the negative fourth, and you punch that in, you're going to get 4. It's nice when they're whole numbers. And the POH, remember, they have to equal 14, so this is going to be 10, because 10 plus 4 equals 14. And then this guy would be 10 to the negative 10th. So sometimes you can do it in your head. Like, it's only if it's like a decimal where you have to plug it in, chug it. So for example, here it's POH is 9, right? So this would be 10 to the negative 9th, which again, people write that like that way. And then this would be 5, and this would be 10 to the negative 5th. So that's how you find the pH of these things as you go. Now this is the chart where I've been trying to draw it, and it's just a beautiful chart, right? So it's just everything you need to know. So this right here is it, right? Like, if you have this, you have it all. So oftentimes you'll have to do like the pH, the POH, all that kind of stuff. But if I'm trying to find the POH, that's this guy right there, and I have the H plus. Okay, so we're going to find the pH and then the POH of this. So I'm going to start, and it's right here. See how it's the concentration? And to get to pH, I have to negative log it. So we're going to go back to our calculator, and we're going to type in, why are you doing that? All right, we're going to type in the number. Let's clear this. So it's 1.5 times 10 to the third. Oh, times 10. Whoops, I did the wrong one. So 1 times 10 to the third. I'm just going to type it in normal notation because it's easier. 0.0015, right? And then we're going to log that and make it a positive number. So if you negative log it, it's on your calculator, just type in negative log that number and it should work. And so what I get is I get 2.82. So 2.82 is my pH. That's this guy right here. And then I would do 14 minus that, or I guess that would be 11.18. That's my POH. And that, my dear students, is what you need to know, is how to go and use this like chart to get between those. And that, I think, is it. Oh my gosh. More Bernie, more dumb. Oh, these are the same memes. It's very disappointing. Okay. Yeah. So there you go. That's it. We are done.